In this video, we will discuss about the feed-forward neural networks and backpropagation error. What is meant by feed-forward neural networks? These are artificial neural networks where the connection between units do not form the cycle. These are called feed-forward neural networks because the information only travels forward in the network, no loops from the inward, then through the hidden nodes if the present. The hidden nodes, these are the hidden nodes, these are the input nodes, and these are the output nodes. And from the here, how these feed forward neural networks sums was being solved. Here the weights w1 into x1 weight sum plus bias, we add the bias, and then this activation function is used. Why this activation function is used? Activation function will decide whether the neurons input to the network is important or not in the process of prediction using simpler mathematical calculations. Generally we use the sigmoid function, which means 1 by 1 plus e power minus z. We can use the tan h function, ReLU or leaky ReLU too. The artificial neurons are simply computational units that have weighted input signals and produce an output signal using the activation function. And from here for this in was w1 i1 plus w2 i2. For this w3, for this h2 in was w3 i1 plus w4 i2 plus bias 1, and this gives the h2 in. If we substitute in the activation function, that gives h2 out. This becomes the input function of this O2 and O1, and then we calculate the for this output and this output same as how we calculate for H1 and H2. After getting these values, generally I solved this problem and I got the value of 0.769 and 0.7563, and this for this for the target and the output and the targets were different, so we should use the back propagation to minimize the error. How this back propagation of error, what is mean by that? The weights of the network are trained so that the error goes downhill until it reaches local minima, just like the ball rolling under the gravity. Here we can see for E total half summation of half target minus output. Target nothing but here what we give 0.01 and 0.99. These are the targets, and the output are 0.7563. I said right, these values where I've been computationally I said, and these values are being calculated. These are the total error, and we can propagate back by using the formula. We can change the error. For w5 I change this. For w5 I would say about this, how this weight was being changed. This can be changed by using this chain rule, dE total by dw5, but E total didn't have any term which was related to w5, so we use the chain rule, partial differentiative. This chain rule nothing but this E total contains error total contains output of O1, that's output of O1 contains net of O1, the net of O1 contains dw5, and this is the formula chain rule. And if these both cancel and these both cancel, same dE total by dw5. This is known as chain rule. Generally it was used for these problems like back propagation. You should listen carefully because it might confuse you.